Here's the solution for Day 2, Problem 1. In question A, identify the x-intercept and y-intercept for the graph of this equation. And then in question B, we'll graph that equation. So question A, we're first asked to find the x-intercept. The x-intercept is a dot on the x-axis, and any dot on the x-axis has a 0 for a y-coordinate. So I can find the x-intercept by putting 0 for y. That's going to create this equation. Four times 0 is just 0, so that there's a 0 right here. So this is like having x equals -6. And that's the x-intercept. As an ordered pair, -6, 0. Now the y-intercept. The y-intercept is a dot on the y-axis, and any dot on the y-axis will have as its x-coordinate a 0. And so we can find the y-intercept by filling in a 0 for the variable x. It's going to create this equation. Zero is like having nothing here at all, and so this could be rewritten as just 4y equals -6. Divide both sides by 4, and that's -6/4, which reduces to -3/2. As a mixed number, this is -1.5. And so our y-intercept as an ordered pair could be written as 0, -1.5. So here's the x-intercept, and here's the y-intercept. We can use those ordered pairs to find dots on the grid. Start with the x-intercept, -6, 0. So from the origin, go to the -6 on the x-axis and put a dot. And now the y-intercept, 0, -1.5. Start at the origin. Let's find -1.5 on the y-axis. And then draw a line through these two dots. Now, Day 2, Problem 2. The value of an automobile, V of t, is a function of its age in years t. A vehicle is worth $24,000 new and depreciates $2,500 each year. Question A, write a function equation for the situation. So we're going to write an equation that uses these symbols and numbers in the problem. And the equation is going to show us the relationship between the value of a vehicle and its age in years, because the value of a vehicle is often dependent on how old it is. So our equation is going to begin V of t. The value of a vehicle after t years is what these symbols mean. The value of the vehicle is $24,000 when new, so that's its initial value, but then it depreciates or loses value each year. And so we're going to subtract 2,500 times t, where the letter t is representing the number of years. So every time t increases by 1 unit, we subtract an additional $2,500 from the value of the vehicle. Now in question B, we can use this function equation to find the value of a vehicle that's 1 year old and of a vehicle that's 4 years old and then 8 years old. Let's find V of 1. What is the value of a vehicle after 1 year? 24,000 subtract 2,500 times 1. 2,500 times 1 is 2,500. So what is 24,000 subtract 2,500? That's $21,500. Now let's find V of 4. $24,000 to begin with, but then subtract $2,500 per year for 4 years. How much is this? Well, 2,500 times 4 is 10,000. So 24,000 subtract 10,000 is $14,000. Now let's get the value of an 8-year-old vehicle, V of 8. That's $24,000 when new. Subtract 2,500 times 8. Let's see what this is equal to. Since 2,500 times 4 was 10,000, then 2,500 times 8 is 20,000. So 24,000 subtract 20,000 is $4,000. Our vehicle when new is worth $24,000, but when it's 8 years old, it's only worth $4,000.